for those students that are not with us right now. And we're going to talk about equations of a line. So what I would like for you to do first is to take a few minutes, graph this data, draw a best fit line, calculate the slope. All right? So you're going to graph this data, you're going to make a best fit line, you're going to calculate the slope. If you need a calculator or a ruler, they're on the back counter. Okay, you're fine. Look back at your notes if you need to decide or figure out or look at what I want to see when I look at your graphs. Okay? Use those notes that we took. Oh, you gotta yell for me.
What's the length measured in? There's no unit.
Oh, that's a good question. What do you guys think?
Meters.
Meters? You can pick whichever one you want. If I'm working on this, because I give you guys time to work, you gotta yell for me when you have a question. Otherwise, I'll let you sit there with your hand raised because I won't see you. So just yell for me. Okay? Thank you, Mrs. Wheeler. What do we think? 5 more minutes? Okay, 5 more minutes. Okay, so I feel like the majority of you have it graphed and you're working on your slope. So let's go ahead and talk about this data. And it's a perfect opportunity for us to talk about a sketch, because at some point we will be using these whiteboards over here, and you'll graph in your notebooks like you've been graphing. Make a nice, neat graph, but you're gonna sketch it on one of those boards. And what I have is my my students who like to have everything nice and neat and perfectly lined up and all of that other fancy stuff. You take 6 hours to graph it on the whiteboard, and then by that time we can't have the discussion because class is over. So when we draw a sketch, you've graphed it nice and neat in your notebooks. We can always go back to your notebook. You can always reference your notebook. You can pick the points out to calculate your slope in your notebook. You don't need that on your graph, right? So, if I'm gonna sketch a graph of this, first of all, which variable is my independent variable?
The amount of time or initial.
So, this first column, right? The amount of time from our initial measurement. That's our independent variable. Does that go on the horizontal or the vertical axis? Horizontal. So, I'm going to put down here, I'm going to abbreviate it, amount of time from initial measurement. And that's in hours. Okay? So, that's our independent variable, goes on our horizontal axis. Our dependent variable then is going to go on our vertical axis. What's that? Length. Now, I picked this data set because this is typically how we label our data tables. This is how I want you to label your data tables. It takes us a while to get there. We have our title here with our units, and then I always get students, because we're using meter sticks, it's obvious to you what you measured in, but it's not obvious to everybody else, and you just put length here. So how many of you use meters? How many of you use centimeters? How many of you use something other than meters or centimeters? What did you use?
Inches.
Inches. Yeah, so inches in here is like a dirty word. I mean, it's up there with like, I don't know, biology. I'm just kidding. I don't hate biology, I just don't enjoy it as much as this stuff. We use the metric system. So it doesn't really matter which one you picked. I'm gonna go ahead and go with meters because it looks like that's what the majority of you use. But this is really important that you get your units on there. Because if I ask for your data to give to someone else and you don't have all your units labeled, how are they gonna know how to do anything? Right? They can't interpret their slope and they're not gonna be able to interpret their equation either. So I'm gonna go ahead and do that. All right. So length in meters. There's no title for this graph. So how do we label a graph with a title that doesn't have a title?
Just come up with a title yourself.
How do we do that? Graph one. Don't do graph one, because that's not descriptive. Go ahead. Yes, amount of time versus length. We always list our dependent variable, then our independent variable. Our independent variable versus our dependent variable. So amount of time versus length. Now, here's the beauty of a sketch. I'm not going to put any tick marks up there yet. All right? And I'm not going to put any points on there yet, because you've already done that in your notebooks. All you have to draw is your line. So is your line, is it a straight line? Okay. Is it a positive slope, a negative slope, or a zero slope? Positive. So is it steep or not steep? Not steep. So from that, does it go through the origin, or does it go above or below? Above. So from that information, is that consistent with what you've graphed? Too steep? Okay. So, in general, that's how we make a sketch. That's kind of the same steepness, but sorry. That's what I would expect to see on your graph. Now, important points. Like, what 2 points did you pick for your slope? So maybe in your notebook, you know what points you picked for your slope. So maybe you picked one down here at the beginning and you would pick one in the middle. This is where I would actually label on my axis what those points are. And that's pretty much all I put on my sketch. Does this give us a picture of what you took the time to graph in your notebooks? This is a sketch. Do we see the difference? This took way less time than I gave you to make the graph in your notebook. Okay. So So now, who wants to tell us their slope? Because I did not graph this and I did not calculate my slope. So, Rachel.
My slope, I got 0.125 meters per hour.
Okay. Madison, is that similar to what you got?
Yeah, I got 0.13 continuing on forever.
Okay, so we don't talk about continuing because that's exact. Right?
So,
Same thing as a fraction. So we just cut it off. 0.13. Okay? Sam?
I got two hours over meters. I don't, am I wrong there?
I don't know.
Okay.
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 What, yes, you are wrong. What is wrong with this?
the hours are over meters.
Yeah, so you flipped it over.
Okay,
We have to do vertical over horizontal for the slope,
gotcha.
okay? Yes, Danica.
I got 0.15.
0.15?
Yeah.
Are these two numbers here, I'm just assuming that we can say that Madison's 0.13 is the same as this, it's just rounded. Are these two close enough together to say that they represent the same data? Yes, those are close enough. Okay, then,
I have 0.7.
you got 0.7?
I got like 0.28.
You got 0.28.
I got
Daisy?
0.457.
0.457. Ethan?
I got 0.43.
0.43. So what's going on here?
I used exact points from the table.
Mine is just different.
Does your line go through those same exact points? Ah. So remember when we calculate slope, they have to be 2 points on the line. You have to pick off 2 points on the line.
That's what I did.
Okay, so what about Zane took 2 points off his line. Ethan, did you take 2 points off your line?
Yeah.
So why are their values so different?
Their best fit line.
Their best fit line is different. Now, I purposefully picked data for you that looked like this because really, and we're not gonna talk about this yet, but really, it should look like this. That's not a line, but that's kind of what your data looks like, right? Yeah. I purposefully picked that because your data is not always gonna fit nicely. So it really depends on how you drew your line. Now, as I was walking around, I saw some of you drew your line more with that first part of the data, and some of you drew your line with more of the second part of the data. But your line has to capture all of the data. All your lines are going to be slightly different, and that's where I get to make the judgment call. And I might, when I'm walking around, say to you, hey, so are you capturing most of your data with your best fit line, or just the beginning, or just the end, or just the middle? And those are things that I will do, okay? So anyway, we all drew a best fit line, calculated the slope. We've got a variety of slopes, and that's okay. That happens. Have we done all that already? Like, are we where we've learned the stuff for? Okay. So now we gotta make a best fit line, or we gotta write an equation for our best fit line. So we're gonna go ahead and we're gonna use this initial slope that Rachel gave us. And we're going to write an equation for this line. So what's the slope-intercept form of an equation? Y equals mx plus b. It's like you guys have memorized that or something. I'll change colors for dramatic effect. Okay. So in science class, we don't use x's and y's. We don't have x's and y's on our graph. So it doesn't make sense for us to use x's and y's in our equation. So I want all eyes. I will give you time to write down whatever you need to write down, but I want all eyes up here. Okay? So the first thing we have to do is we have to pick variables for our axis labels. For length, what do you want to use to represent length? L, that seems reasonable. I'm going to use a capital L. What do you want to use for amount of time from the initial measurement? T? We're okay with T? That's my lowercase t, so that you don't get it mixed up with a plus sign. Alright? Okay, so we've got our variables. Step one done. Variables identified. Next, we're just literally gonna go step by step in the equation and replace what pieces we have there with the pieces from our graph. Okay? So, I don't have a y on my graph. What do I have in place of y? L. So I'm gonna put L equals. What's M? Slope. Well, you calculated the slope already. So I'm going to replace the M with this slope that we have. Okay, again, I want you guys to watch me. I'll give you a chance to write this down when we're done. So here's how I want you to do this. We're going to put it in parentheses because there's numbers and letters in there, and we don't want those letters to get mixed up with these other letters that we're putting in there. So we always put our slope in parentheses, and it always must contain the units. So I'm going to put in parentheses 0.125 meters per hour. Does everybody see what I did? So we've taken care of this. We've taken care of this. Now we're at x. What do we have on our graph in place of x? T. So I'm going to go ahead and put my t. That replaced that x, which is ironic that I put an x over an x. And then plus. What's b? It's your y-intercept. So this is going to be slightly different from everybody, but Rachel, since you give us the slope, why don't you give us approximately where your y-intercept is? What value do you have?
27.
27?
Yeah.
And what unit do we use for that 27? Meters. Why do we use meters instead of hours?
Because it's on your y-axis.
It's the y-intercept. So this is our vertical axis. This is what the unit is for that vertical axis. So there's our unit. How do we feel about that? Need some practice? Yeah. Okay, so go ahead and write down whatever you need to write down. We literally just went piece by piece by piece and just replaced it for what we have on our graph.
Mrs. Foley,
Yes.
I'm still trying to understand where she got the 27. I know.
My best at line.
Yeah, that's this point right here where the line hits the vertical axis.
Okay, gotcha.
Okay? So that is our y-intercept.
Gotcha. Okay.
Does that help?
Yes.
Okay. Do we have any other questions?
I just have a question in general. So you know how our best at line is supposed to be straight with a ruler?
Yes.
You know how you did that curve line?
Yes.
You want us to do that like in the future or not?
Nope.
Okay.
I will, when we get to that point, I will talk about it, but for right now, almost everything we deal with is going to be linear.
Okay.
Annika?
I need help over here.
Okay. Your y-intercept is 0. That's our process. Okay, so is that something you feel like you can do? Will you try to make it harder than it is?
Yes.
Of course you will.
Already did.
All right, so you said you need to practice, right? All right, I'm going to erase this. We ready? It's like we did nothing. Oh, too late now.
I know. I just.
Yeah.
I'm just so funny, aren't
I might feel bad if I probably don't. So. So I went ahead and graphed this one for you and drew a best fit line. Actually, I had the computer graph it and draw a best fit line. And this is the same data we just did. Okay? Now, like I said, I just entered this information onto the computer, and I had the computer generate that best fit line. So, does it match what you guys got? Yeah? The y-intercept is about 19. This is an in centimeters. I pick centimeters. Would that be, I mean, since this is what the computer generated, the computer will generate this same graph every single time. It'll give me the same exact line every single time. So what do you think about that? Does that make what you guys did wrong?
No.
No, you're not computers, which is good. I will not have you graph on computers. I will have you graph by hand every single time. Because you need practice graphing by hand. Trust me. I don't even let my chemistry students graph on the computer. It's all by hand. All right, so let's move on to this one. So I have this graph. I'm going to ask you. I put the best fit line on there. I'm going to ask you to take this information and write the equation for the line. So if you need to move up here so you can see whatever you need to see, you can do that. I'm going to give you just a few minutes to go ahead and graph, or I'm sorry, to write the equation for the line, and then we'll talk about it. Okay? We about ready? Let's see. I should have figured this out in advance. So, who wants to share their slope? Elena.
1.25.
And what would the units be for that?
Negative.
Negative?
Years over hours slash weeks.
Years over hours
Yeah.
per week. Ooh, that's a weird unit. Okay. Did everybody get something similar to this? Did anybody get something way different? Same?
I got -1.26.
Negative 1.26. Zane. Sam?
I got negative 0.83.
Negative 0.83. Same units, different?
Same units.
Same units. Years over hours per week. Okay, Ethan?
I got -0.75.
Negative 0.75. Same units or different? Same units. Years, hours per week. What do you think? I would say that these two are similar enough to each other to say that that's okay, but this group and this one are two different.
Mhm.
So, what do you think? What do we do?
I don't know why they're different because a computer generated it, so it should be the same. Because how it's measured and how it was graphed is the same, you know what I mean?
It's also by the user, how you look at it.
Yeah.
And how you look at it?
Yeah.
So I purposefully put on here all the minor grid lines so that it would be easier to pull those numbers off. Now, let me see if I know what we did. Which I do. Okay. So the value I got was bigger than 1. A negative value that's bigger than 1. So I'm inclined to say that this one is correct. These two values here, my guess is you flipped it. Because if I flip the fraction that I got, I get 0.73 or something like that. So you want to be very careful to make sure that the points are in the proper place. Roughly, the way that you can check that is we're going from about 42 down to 35. That's a change of about 7 in the vertical direction, over 5 in the horizontal direction. So I would expect a slope bigger than 1. Does that make sense? Okay. We'll be working on slopes all year, so I don't want you to panic. Okay, so let's use Elena's number. And who wants to help me write the equation? Annika? All right, so first step, we got to figure out variables for our axes. So what do you want to use for age? A. And what do you want to use for internet usage? I. Okay, so I need to say right now that when you use an I in here, it's got to have the bars over the top and bottom, because if not, it looks like a 1. So be very aware of that.
It's still a 1.
Hmm?
It's still a 1.
It's still
Roman numeral.
It is a Roman numeral, but we don't use Roman numerals in here, that's chemistry.
Oh.
Okay, so I'm going to go ahead and write up here. If you need to write this down, then write it down, because that's the form in the equation we're always going to use. Slope-intercept form, and we're just going to go piece by piece. So Annika, what is on our y-axis? What am I going to replace that y with? A. Equals slope. And then the units go in parentheses with the number. All right? So we've taken care of this part and this part. We have an X here. We're going to replace that with an I. And then plus, and what did we say B was again? It's our y-intercept, but what value do we want to use? 42. And what unit does that get?
Years.
Years. I mean, this is graphed on the board, the lines are tiny, it's not real dark, it's hard to see, I get that, that's why we have a little bit of variation. That's okay. Now, what this does for us is it allows us to predict. If I know a person's age, I can predict what their internet usage would be. Vice versa, if I know their internet usage, I can probably predict their age. Is it going to be right 100% of the time? No. And that's because the data we have doesn't fit that line perfectly. And there's a lot of variation in people. My father-in-law this morning learned how to use a smartphone for the first time ever. Okay? So he's probably going to be like at 0, but he's going to be way up at the top. However, my children they have a restricted amount of time they can use their internet. So even though their age is going to be lower, they're still going to be over here in the lower numbers for internet usage. So there's a lot of variation in that. Okay? That equation is specific for this graph. It's specific for this set of data. It is specific for the topic or the content that we might be graphing. That's how we use graphing in physics. Do you have any questions? So, what I would like, we have 2 minutes left. What I would like for you to do, okay, hold on, let me think about that. I think we are going to start the lab tomorrow. We're going to start the lab tomorrow, which is good because 7th period on Friday will be disrupted. So we're going to start our lab tomorrow. I am going to put you into groups and yeah, I'm not going to tell you what it is. I'll pose that question tomorrow, and then I'm just going to kind of like give you your materials and let you go. I think that's not going to work. You need to make sure that you have your notebooks with you tomorrow. You should bring them every single day. Everything we do should go into those notebooks. If you have any questions about what we've been doing, or you need to like have that lesson again, I have been posting the videos that I've been recording in Classroom. So they're there for students that are missing, but they're also there for you if you need a lesson again or you just need a refresher.